Our planet has a very general pattern of the way that air circulates between our equator and our poles. And all of this is caused because the surface of our planet is not heated equally in different areas. So depending on whether we're at the equator or the poles, we're going to receive different amounts of solar radiation, or sunlight and heat from the sun. Around the equator, these low latitudes, it's going to be very hot because it's getting most of the sunlight. Whereas in our polar regions, it's incredibly cold because it's getting very little, if any, sunlight at all. So based on the differences in heating along different latitudes on our surface, we're going to get three types of atmospheric cells, or three different ways that each hemisphere is going to circulate air from its hot equator to its cold poles. So if we look at the equator itself, this is going to be called the equatorial low pressure zone. As the name suggests, it's found around the equator and it's an area of low pressure. Because it's low pressure, here the air will be rising, and as it rises through our atmosphere, it's going to cool down. Once it cools down, it's going to precipitate, forming our rainforest around the equator. This is also where the intertropical convergence zone is, where we have the interaction of air between our northern and our southern hemispheres. If we move to about 30 degrees north or south of the equator, now we'll be in a subtropical high pressure zone. It's subtropical, meaning it's not right in the tropics at the equator. It's a little bit above or below it at 30 degrees. But here it's a high pressure zone. So we have air that's subsiding or sinking from higher altitudes to the surface. And as it's sinking, subsiding air, it's going to be very dry. So because it's dry and it won't lead to precipitation, it's going to be where the deserts on our planet originate. So this map is showing us our low pressure around the equator and our subtropical high here around 30 degrees north. Remembering that air does not like to be under high pressure but instead flows to low pressure, when we are looking at wind on our planet, it's going to blow from 30 degrees north or south of the equator from this high pressure zone to the equator. And we call these the trade winds. Back in the day when we were only surviving and getting around on large boats and ships, we would use these trade winds to trade goods between different countries. But in addition to the high pressure zone at 30 degrees north and south of the equator, our poles, the north and south poles, are high pressure zones as well. So we also have high pressure escaping our poles and moving farther down towards our subtropical highs, and these are going to produce winds that are called the westerly winds. With these areas of high pressure along our poles, because it's high pressure, we'll have air that is subsiding or sinking from high altitudes down to the surface. Again, because it's high pressure, it doesn't have a lot of moisture, so there won't be a lot of precipitation. And we're going to see that as that air spreads out or diverges away from this high pressure center, it's going to create the polar easterly winds. And this is going to collide with the westerly winds to create the polar front. If you listen to the news in the winter and they talk about the polar front moving through New York, this is when they're going to receive like 6 or 8 feet of snow in a single day. But beneath this high pressure area right at our poles, we also have subpolar low pressure areas at about 60 degrees north and south of the equator. And here we're going to have both warm and cool air interacting, and it creates lots of these polar front storms.